Hi everyone, Miss Nardini here. And the first thing I want to do is talk about a few things that we learned in the last lesson that we will continue to use today. So we will be doing the factor and remainder theorems. So we talked about the remainder theorem in the last lesson. So this is a little bit of review. The remainder theorem says that if a polynomial f of x is divided by x minus k for any k, then the remainder r equals f of k. So whatever this k value is, if you plug that in for x, that is the remainder. So the additional thing that we will be learning today is the factor theorem. So this we haven't talked about before. So the factor theorem says that a polynomial f of x has a factor x minus k if and only if f of k equals 0. So whatever this k value is, as long as when you evaluate the function f for that value of k, the outcome is 0, then we know that x minus k is a factor. So we did this when we talked about binomials and quadratics. Our factors were in the form x minus k, and when we set them equal to 0, we could solve for the 0, or the solution. So the first type of problem that we are going to do is factoring a polynomial. So factoring a polynomial example 1. We're going to factor f of x equals 2x to the third plus 11x squared plus 18x plus 9, given that f of negative 3 equals 0. So we're going to use the factor theorem to figure out what our first step should be. So we're told that f of negative 3 equals 0. And the factor theorem says that the polynomial has a factor if and only if f of a certain number k equals 0. Well, in this case, negative 3 is what that k value is. So since f of negative 3 equals 0, then x minus negative 3 is a factor. And we know this from the factor theorem. So instead of saying x minus negative 3, we can say just x plus 3 is a factor. So we're going to kind of put that on the table till we finished the rest of the problem. So now we know one factor. To find the rest, we use synthetic division. So remember, with synthetic division, we use the coefficients given in the original problem. So 2x to the third plus 11x squared plus 18x plus 9. And we know that negative 3 is a 0. So when we make our box, negative 3 goes in that box. So and then I use my coefficients, 2, 11, 18, and 9. And remember, synthetic division, the process is always the same. The first thing I do is bring down that first number. Then I multiply whatever number is in that box by the first number. So negative 3 times 2 is negative 6. And then I add down the column, so that's 5. Then negative 3 times 5 is negative 15. Again, add down the columns, I get 3. So then negative 3 times 3 is negative 9. So my remainder here is 0. So now my answer, or my new factor, becomes 2x squared. Remember, we started with x to the third, so our first term in our synthetic division answer is x squared, and so the coefficient is 2, plus 5x plus 3. So that's what we get from using synthetic division. So this 2x squared plus 5x plus 3 is a factor, and x plus 3 is a factor. So I know that when I factor the original polynomial, I start with 2x to the third plus 11x squared plus 18x plus 9. And they told us that x plus 3 is a factor. And then we found that 2x squared plus 5x plus 3 is a factor. We need to make sure it's factored completely. So, since we have a trinomial here, we're going to use the guess and check method. So the x plus 3 stays in front, and I need to make my two sets of parentheses. So if I have 2x squared as my first term, I need 2x and x. Then I have 3 to be multiplied for my last term. Well, the only factors of 3 are 1 times 3 are 3 times 1. So we just have to make sure we choose the right combination. If we choose 3 and 1, when I multiply my inside, I get 3x. My outside, I get 2x. Which, if those are both positive, I get positive 5x. Which is exactly what I want. So I have 2x plus 3 and x plus 1. So your final answer, when they say to factor a polynomial, which was our directions, is x plus 3, 2x plus 3, and x plus 1. Those are the three factors of the original polynomial. And so that is it for factoring a polynomial. The second type of problem you're going to see is finding zeros of a polynomial function. So let's write that down. Finding zeros of a polynomial function. And this will be example 2. 1 0 of the function f of x equals x to the third minus 2x squared minus 9x plus 18 is x equals 2. Find the other zeros of the function. So what they did here is say they gave you the function and they told you that one of the zeros is x equals 2. So what they're doing is they're giving you 1 0 and you have to find the rest. And how we're going to do that is by factoring. So if we know that 1 0 is x equals 2, then it means I know that f of 2 equals 0. And by the factor theorem, I know that x minus 2 is a factor. So knowing that x minus 2 is a factor, I can use synthetic division. So I want to make sure you all have this written down. So if you need to, pause now, make sure you have everything written down, and then we can move on to the next problem. Alright, so our original polynomial was f of x equals x to the third minus 2x squared minus 9x plus 18. And we knew that x equals 2 is a 0. So when I make my box for synthetic division, my 2 goes up in that top left corner, and then I write down the coefficients of my polynomial. So 1, negative 2, negative 9, and 18. Bring down the 1 first. 1 times 2 is 2. Negative 2 plus 2 is 0. 2 times 0 is 0. And then negative 9 plus 0 is negative 9. Then lastly, 2 times negative 9 is negative 18, which gives me a remainder of 0. So now, my other factor for my polynomial, we know the first one is x minus 2. And then from the synthetic division, these coefficients tell me that I have x squared plus 0x minus 9. Now you don't need to write that 0x there, right? we can all know that if you have 0x, it really just doesn't exist. So x squared minus 9. So now I just need to make sure I'm factored completely. X squared minus 9 is a difference of 2 squares. So f of x equals x minus 2 times x plus 3 and x minus 3. And now the directions for this problem told you to find the other zeros. So we find the other zeros by setting f of x equal to 0. So x minus 2, x plus 3, and x minus 3. So now you don't necessarily have to write all this next part down, but if it helps you, please do so. I'm going to, so you have it in your notes. I recommend that you write it down now, but on all the problems you do in class, you might be able to get away with not writing it down. So this whole, if these three factors multiply to 0, then each of these factors have the possibility of being 0. So x minus 2 equals 0, x plus 3 equals 0, and x minus 3 equals 0. I'm just setting each factor equal to 0. So x equals 2, x equals negative 3, and x equals positive 3. And those are the three zeros of the function f. And we did this by using the factor theorem and synthetic division. So those are the two examples I have for you today. If you have any questions, I really truly recommend rewinding, watching it one more time, making sure you have everything clear and ready to go on your notes. And feel free to ask questions as soon as we get to class. See you then!